section 6.1, was it? Yeah. We were interested in finding the area under a curve. We said, okay, fine. If you had two curves here that they do some intersection, and you wanted to find the area from A to B, then actually you find where the top function is, where the bottom function is. So you split that as C, and I said if I want to calculate this area, if this is your F and this is your G, then something is seriously wrong with this. Then we say that the area itself is equal to the integral from A to C, and this is F minus G dx, and then plus C to B, and then it becomes G minus F actually. This is a dx, yes, because now G is a top function, bottom function. And this can be, of course, can be done as such. You see A to B all together, and you have F minus G, yes, dx. And you know what this is. So if F is greater than G, it becomes F minus G. If G is greater than F, then it becomes minus F minus G, which is G minus F actually. So this part happens when G is more than F, yes. So this is just all of them together. But anyway, these are the details that you really need to be interested in, yes. Okay, fine. So this is how we find the area between two curves. And the idea was just to get again, we go back to the Riemann sum idea, which is to find this is a function, this is another function, is to find a strip, yes, here. So we just we insert a rectangle here, and this rectangle has a certain width, which is, of course, here is a dx, and it has a certain height, which is obviously F minus G. And the area of that rectangle is the height, which is F minus G. Multiply that by delta x, right? Or dx if you wish, they are the same. And you want to add them up. And adding them up in our language means that you need to put an integral sign from where they start to where they end. And see, why did they start here? Because your first rectangle is going to be here. Your second rectangle is here. And your third rectangle is going to be your fourth rectangle, etc. So there will be so many rectangles here, then you need to add them up by the sign, and you have to go from this level to that level. So this is the story of a simple story of just the areas. So in the area is nothing but the integral, but since we're looking for a physical area, you have really to watch which one is on top, which one is the bottom. Yes, that's it. Okay, so let's just go now to the calculation of volumes. Okay, and I hope you listen to me very carefully, because always in the class there's only the first 5 to 10 minutes where I give you the substance of the section, and then the rest is going to be exercises. Yeah? So if you get the idea, then everything will be routinized. In order to calculate the volumes of shapes, let me just start by this example, which is the pyramid. Okay, and let me just put that here. So I tried to do this pyramid, and that gave me a hard time in terms of of these lines. But anyway, let me just remove that and do this by hand. Okay, so this is a pyramid. Okay, for our mechanical engineering friends, we have to cut this, yes, because now this is a hidden line, correct? This is also a hidden line. This is a hidden line, yes. All these are hidden lines, yes. Okay, so I think this is correct, yes. So this is a pyramid, and I'm interested in finding the volume of this pyramid. Okay, do you understand what I'm trying to do as well? And this length from here to here is A, and this is also, let's say, this is also A. So this is a square base. All right, Ashram, is the question clear?
Yes, clear.
Yeah, but there's something missing, which is what, Ashon?
The height.
Exactly, very good, yes. So we have the height. Okay, so that's, let's say it's capital H. So I want to find a formula for the volume of this pyramid. It has a square base, and I'm interested in finding the volume of that. So what do I do? I say, can you suggest anything? Okay, here's my big question mark. What am I supposed to do?
Area of the base multiplied by the height.
Yeah, but that area of the base multiplied by the height should give you a cylinder, yes?
Yeah, if
Right?
it
Find
is an
the area of
organized
each
shape.
surface.
Because this area, and then you just have the same area up, yes? It's just like if you put blocks on top of each other, right? So let's say that these are blocks, yes, right? Okay. So you just have to calculate the area of the base, let's say, multiply by the height, because now you will compute the number of blocks in here. So it doesn't really work for shapes other than the basically cylinders or cubes, right? Okay. But anyway, well, even with that formula, let's say like can do better. So yeah, any other suggestions?
You can do it by delta H.
Delta H, like you're saying that we should take a sample, yes?
Like I'm saying, the area will change when H changes.
Okay, so let's just, your friend is probably saying this. Let's just take a sample here. Okay, so this is okay, let's take a small strip here. You see that strip? And if I may isolate it here, it goes like that. Okay, so what's the area of this? What's the volume of this? Since this is this thickness is just a small thing, all right. So this is the thickness, yes, and this is the area. So obviously the volume, since this is more or less like a square, yes, and this thickness is very small. What does that mean? That the area on top and the area at the bottom of this, which means this area and the area at the bottom, are almost the same, because that is extremely small. What I'm saying is that think of this volume as your uh, uh, paper thin, yes? The papers that you write on is just as thin as that. So the top area and the bottom area are going to be almost the same. So there's no big difference, yes? So the volume is nothing but the area, yes, multiplied by the thickness. Do you agree with me, Asham? Yes or no?
Yes.
Yes.
Okay. And this area, and actually, if we know this, let's say that this is a small area. This is a small a. Okay. Uh, and the area is obviously what? So, and of course, because this is a square, so this is also going to be what? So this is going to be small a. So the area is actually a squared multiplied by the thickness. Do you agree with me?
Yes.
Okay, so that makes sense. If this is just an A from here to here, small a, I don't know what that is, but it's somewhere. And also the width and the length are A and A, so the thickness is just D. Let's say, so the volume is just A squared times the thickness. So that we are done with that, yes? Okay, but how is this related to the whole thing, yes? So if you want to watch this, please listen carefully to this. I would like you to watch this triangle. Okay, let me just make it thick enough. I want you to watch this triangle. Okay. Do you see that triangle?
Yes.
So that
Yes.
passes in the middle of this. And what is the length of this yellow thing here? Okay.
Half A.
Exactly. Let's just isolate that here. And this is what we have here. So this is A over 2. You agree, Ashalam?
Yes.
Yeah, so this is from here to here is just A. So this is A over 2. And now this is also small a over 2. You agree?
Yes.
Yeah. So this small a over 2. And this whole thing is what?
Height.
Is the height, h. And what is this? Where is our sample taken place at? I don't know. Let's call it y. Do you understand what I'm doing, Ashalam? Because I really didn't tell you where the location of that sample is. You see this sample here that we're talking about here? I never told you that the location of that could be up or down, yes?
Yes.
So let's say that this is just somewhere at exactly y. All right? Okay. So now I have similar triangles. Look at this triangle. Look at this triangle with the big triangle. Are these not similar?
They are similar. Yes.
They are similar. So now I know that a over 2 divided by capital A over 2 is equal to what? Is equal to this height, which is
H minus Y.
divided by the big height, yes?
Yes.
Which is h. All right?
Yes.
Okay. So now observe that this thickness here, what is this thickness now? What do I call this thickness?
dy.
Yes, exactly dy, because I'm going into y. So this is the y direction. This is the y direction. Anytime that I cut small pieces here, they are all what, Tashabam?
Dy.
They are all dy's. Okay, so now I can solve for this a, yes? So now this 2 is going to cancel. So a is actually going to be what? Capital A over h multiplied by h minus y. You agree that?
Yes.
Yes.
Okay. So now I'm going to come back and I say the volume of sample. This is the volume sample, yes? And I'm going to call it a dV. What does this D stand for, ya Shamam?
Volume.
A small thing, small volume, yes? Like a
Yes.
dx. What's a dx? It's a small x, yes? dV
Yes.
is a small one. So that's the volume of this strip, yes? The one that I'm just showing here, yes? This is the volume of that. Is equal to what? Is equal, as we said, it's equal to a squared multiplied
dy.
by the thickness, yes?
Yes.
Which is equal, so dV is equal to a squared, which is now a over h minus y. Everything is squared multiplied by a dy. Okay. How many samples can you take here, Yashon?
Infinity.
Yes, these are the samples that you can take. Similar to that. Similar samples. So they go from where to where?
From 0 to
0
From
y
0 to
until, yes, exactly 0 y to h. Now if I so if I want to calculate the volume, I am losing my colors. Yeah, if I want to calculate the volume now, I'll just have to integrate this, which is a over h minus y, whole thing squared, dy from 0 to h. That's how I get it. Okay, let's just simplify this. We know that a is a constant, so this is a squared over h squared, correct? 0 to h. This is h minus y squared dy. You agree, Ajama?
Yes.
Okay, so let's just integrate that, a squared over h squared. And we say that h minus y is equal to u. Okay, so
Okay.
h is a constant, so minus dy is equal to du, correct?
Yes.
So this is the integral from u squared, and dy is minus du, isn't it?
Yes.
And if y is 0, what is u? Is h, yes? And if y is h, what is u?
0.
0. So this can flip also. So this is a squared over h squared from 0 to h of
Yes.
u
Yes.
squared du. So this is equal to a squared over h squared, and then I have u cubed over 3 from 0 to h. So this becomes the known formula that you have, which is 1 over third a squared times h, where a is the length of the base, yes? So this is the length of the base, which is a, and now this is the height, yes? This is h, and this is your pyramid, right? So the volume of this pyramid is 1/3 the area of the base, which is a squared. So this is 1/3 area of base multiplied by what? By the height. And this is the one that you know from geometry in high school. Is that okay, Shabam? Do you understand what that is now? So what is the basic idea here? The basic idea lies in here exactly. Just taking a sample. Okay, and then what do? Sum, which is equivalent to what?
Integration.
Integration. So this is what it is. And this in the middle we have to use some, no, just similar triangles thing. Yes. Okay, fine, fantastic. So this is one way to calculate volumes, and I would like you to go home and do also the do the cylinder, where this has an R radius and this has an H. How are you going to calculate the volume of that? So we take a small sample, yes, somewhere, yes, here, and then the volume of that is pi r squared multiplied by the thickness, which is a dy, if you think that this is y. Okay, and then and this r is just constant, so it becomes pi r squared. This is a dy. You want to go from 0 to h, so you get pi r squared, and then you get an h. So it's the area of the base multiplied by the height, which is a known for a cylinder. Now you could also go further and do the coin. Oh, sorry, the cone. Right? Okay. So the cone. How are you going to do the cone, Asham?
A sample circle.
Okay, fine. So this is h, yes. And let's say that this is r, the big R, yes. So you're going to do this as sample, yes. Okay. All right. So you isolate this sample here, and this sample takes place at what? At a distance y. So therefore, this thickness is what, Asham?
dy.
Is a dy, and this is what? This is small r. We don't know where the
Yes.
small r is, yes?
Yes.
So the volume of this, which is the small volume, is pi r squared multiplied by dy. You agree with me?
I think we should compare small r with big R.
Exactly, but you agree on this? So this is the area of this
Yes. Yes.
space, which is pi r squared, multiplied by the thickness. So you get the volume, small volume. Now what you want to do is that you want to build up on this. So in order to do this, you see you can also have similar triangles here. In this triangle, where this is the small r, right? So this is the small r and this is the big R. So R over R, etc. You can do your business and do the integration again. I'll leave this for you, okay? Okay, so these are shapes that you used to remember the formulas from high school geometry, but now we can have a proof of that. Now what we're going to do now is the solids of revolution. Okay, let's see what we mean by solid of revolution. This is the first example. Okay, it says find. Please concentrate with me, Ashab. This is a very, very important topic. And it is very simple if you just follow what I'm going to tell you now. And you think about it. Generated by revolving the region bounded by y equal square root of x from 1 to 4 about the x-axis. Okay, let's just think about it. So we have a graph which is the square root of x, and the square root of x is actually, it goes like that. So that's the square root of x. Let me just make this smaller again. All right, and we will stop here at 4 actually. So this is x is equal to 4 here. So if x is equal to 4, then y is equal to what? It's equal to 2, yes?
Yes.
So this is y is equal to square root of x. What I want to do is that I want to rotate this about the x-axis. Okay, and please listen to me carefully. So now if you rotate this about the x-axis, so this is what will happen. This point here, if it gets rotated, it will come down here. You agree, Ashon?
Yes.
Okay, and this point here, if it gets rotated, it will stay in place, yes?
Yes.
So now this is going to do this shape. Exactly. You agree? That's the kind of rotation it will do.
Yes, we agree.
And yes, and this curve is going to rotate as such. So this is the shape that you're going to get, something like a pot, yes. So you will end up with this kind of volume. And then we rotated. Remember that we rotated this region here, and I'm just going to mark this, yes, this region. Remember, this was the original region that we rotated. And if you rotate that region, you get this shape, obviously. You understand this, Ashok?
Yes, we understand.
Okay. So what is the idea here? In order for you to find the volume of that, please listen to me very carefully. Okay. Now I'm going to take a sample. Okay. This is a sample. Okay. This is a rectangle, correct? Oh. And I'm going to rotate that rectangle. This is a sample in what? This is sample in the area that I want to rotate about the x-axis. And if I rotate that about the x-axis, and this is exactly what I'm going to get.
What will happen, Doctor, if we made the rectangle parallel to the line of revolution?
Oh, that's a different story. We'll come to that. Okay, but I will take the rectangle now perpendicular to the axis of revolution. Okay. Do you agree that this is going to do this?
Yes.
It's just like a radar ray, and it will just rotate. So it will create this area. Okay, and since it has a certain thickness, then it will go with the thickness, which is that. So this is the area that I'm going to get. Okay, the idea again is about samples. That's the whole idea of volumes. So if you manage to get the volume of that green sample, yes, then we are fine. But the green sample is what, Ashram? Isn't it like a cylinder?
Yes.
So what is this area here? And what is this thickness? That's all I need. this thickness is equal to what? Do you think it's a dx or dy?
dx maybe.
Why is it a dx? Because look at this here. This is
The
a
area
dx.
depends to x-axis.
Yes, exactly. It's a small thickness around the x-axis. Yes. Right. Now, what is this area here? Is a circle, isn't it? Yes.
Yes.
So it is pi r squared. Yes. So
Yes.
now the volume of this element, which I refer to as dv, is only one volume. This volume, right, is equal to what? Is pi, the radius squared multiplied by the thickness, which is I call t. So now let me just see my credentials now. So the thickness is a dx. I know what that is, and the r. So let's look at the r. So what is this r here? What is this? Let's say this r. Okay, this r. Isn't this the r?
It's the height of function.
Exactly. Isn't it the r here? Just look at the graph. Isn't it the height of the function, as your friend suggested? So this is actually y squared of the function, correct? Then what do I do with these samples, Ashamo?
Take the integrate of
I add them up, yes, because there will be plenty of these green samples, yes. So what I will do in order to find the volume, I will just integrate these pi y squared dx from where to where?
1 to 4.
From 0 to 4. Okay, but you see, there's only one little problem, and I'm integrating with respect to x. And what do I have here?
Y. But
I have a y, but this is y of the function, yes. And y of the function is what?
the root of x.
Exactly. So this is 0 to 4. This is pi square root of x, and then squared, and then dx. So what do we have here? I have a pi. This is 0 to 4 of x dx, which is equal to pi. This is x squared over 2 from 0 to 4. So this is what? I don't know what you get. You get what? Any idea what you get? Yes or no?
8 pi.
16. 8, yes. Right. I could have done this from any other place. Like just, it doesn't have to be from 0. I could have done it, for example, from here 1 to 4, whatever. Right?
The question asked from 1 to 4.
Yeah. Oh, this is 1. Okay, we change it to 0. Yes. All right. Okay, just put it 0. Yeah. Anyway, the original question was 1 to 4. I forgot. Yes. So this is from 0 to 4, but you can do it from 1 to 4. So it will just, you will just have to integrate from 1 to 4, basically. Yes. Okay, so let me just show you how this behaves. Okay, let's see. I did something for you this morning. This is not going to work out. This is the new unlicensed software. I don't have a license for that. I have a license for the previous one, which is version 10. Okay, let's see. So this is the, well, again, this is from A1 to 4. Okay, let's see what happens. So this is your graph, isn't it, Asham? Please listen, Asham. If this is your graph from 1 to, this is the square root of x, yes?
Yes.
All right. And I'm going to rotate this about the x-axis. So I take a sample. This is the sample. So what's the thickness of this sample, Asham? Is it dx, isn't it?
Yes.
Okay. And let's just rotate that and see what happens. So if you rotate that, then this is, I'm taking 2 samples actually, just for you to see that. See, these are the samples. See, this is what happens to it. If it rotates, it becomes what? A circle, yes? And the thickness is still what? What is this thickness?
dx.
Still a dx. So all what you need to do is just get the area of this circle, multiply this by dx. So what is the area of this circle? Well, actually, the area of this circle is this height squared times pi, isn't it?
Yes.
If this gets rotated, then it stays the same. So this is the height that we looked at. This is the y, and the area of this circle here, which is, now you can see here. What is the area of this circle? Is nothing but pi r squared, and r is nothing but the height of the function. right? And all what you need to do is just have all these samples together. I will just put 2 samples for you, but how many are we going to have? How many samples we have? Infinitely many, and they will go from where to where? From 1 to
4.
1 to 4. Then you have to put an integral, which means you will add all these up. So it's a matter of sampling. You just get a sample, take the size of that, and then you're done. That's it. Okay, let's go back. I hope this is clear, Shabab. So the rotation business is simple. If you understand that, then we're almost done. The rest of the thing is going to be just what was the second example here in the file? Let's see. We have x squared from 0 to 1 and square root of x. Okay, let's just do another one. Another example. I have f of x, which is x squared, and g of x, which is the square root of x. Let me see that. X squared, the square root of x from 0 to 1. 0 to 1 about, I'm not going to write the whole sentence, yes, about x-axis. So you want to rotate the region that is bounded between these 2 graphs from 0 to 1 about the x-axis. Okay, so as a matter of graphing, so you know how to graph this. It's very simple. Okay, let's see. This is your x-axis, and this is your x squared. Okay, and this is the square root of x. Okay. Okay. So this top function actually is the square root of x, and this bottom function is the x squared. Okay, and obviously the intersect. I'm not going to do the intersection. You do it, Ashraf. It's very simple. The intersection is at 1 and 1. Yeah. You agree with me, or you want me to do the intersection of these 2?
Yes, we agree.
Just equate. Let me see. That's it. And where do you want to rotate that, Ashraf? About the
Around
x-axis. X-axis. Okay, so let's see what happens if you rotate this point here. Where does it go, Ashraf? Yes.
1 minus 1.
It goes here.
Yes.
Correct. And if you rotate this point, it doesn't go
stay.
it doesn't go anywhere. So this is going to come up. And this is the shape of the object that we're going to get. So this is hollow. There's nothing in here. Okay. And this is full of material. Yes. See that, Ashram? Is that okay?
Yes.
Okay. How are we going to calculate the volume of this? Do you understand that the volume is filled here? We have a volume here. Yes. And we have material here, but the rest is just empty. There's nothing. Yes.
Yes.
Because we are rotating what? The region between the 2 graphs. Is that okay, Sean?
Yes, okay.
Yeah, so how do we do this? We take a sample, correct? Yes, take a sample here. No. Okay, this is the sample. And this sample is just only a rectangle between the 2 regions. This is, of course, this sample is representative because you can put it here, you can put it anywhere that you want between the 2. Do you understand what I mean by a sample?
Yes, we understand.
Okay, fine. And we are going to rotate that. So if you rotate this, it gets you here. And let's look at the rotation. This point is going to rotate as such. And this is going to rotate as such. Okay. You see that?
Yes.
Okay, so that we have this volume now. that we really want to calculate. And of course, we have a certain thickness here. Okay, fantastic. So let me just isolate this object out. Okay. Okay. All right. I want to find the volume of this guy. Right. So what is the volume? Actually, it's well, this is just like a small cylinder. And what's the area? What is the volume of cylinder? Is pi r squared multiplied by the thickness, isn't it? Tamam shabab. If you have any cylinder, it will be the area of this fellow, which is actually pi r squared. Yes.
Yes.
And multiply this by what? By the thickness.
Yes.
Now, but this is what you can calculate the volume of the outer cylinder minus the volume of the inner cylinder because there's nothing inside here. Correct? So now I'm going to do this. So this is your R1 and this is your second radius. So the volume of this guy is what? Is pi R2 squared multiplied by the thickness. Let me just put this as T. Minus pi R1 squared times the thickness. That's it. So this is my dV, the volume of this sample. Yes? Is that fine?
Yes.
Okay, so let's just translate that. What is the thickness here, Hisham? Is it the dx or a dy? Remember when we took the sample here, this sample?
dx.
It's a dx, exactly, because that sample we took it as such. So from here to here was a small x, so this is a dx. And we rotated that. That's what we did. Okay, so now, so this is a dx. We can figure this out. So now let me just take the pi out. And this is my dx. Now let's look at R2. So what is R2 here? Isn't this R2?
It's the function root of x.
Y top function.
Yes, y top function.
Square.
Yes.
Yeah, because that's R top function and minus what? Y.
Down function. What was?
Exactly. Okay, the bottom function. And then a square. That's it. And then what do if I want to find the total volume? What should I do with the total volume? Put an integral sign. This is pi. What is the top function? Now, see, like these are y's. These just don't go with this x. So I have to exchange them. What is y of the top function?
Square root of x.
Square root of x. If you square it, what do you get? Okay, let's just keep it as such. Yes, the square root of x and square minus the bottom function is x squared, and you have to square it, and this is a dx. And they all go from where to where?
0 to 1.
0 to 1. You see the samples. Remember the samples? Yeah.
Yes.
So they go from 0 to 1. So this is from 0 to 1. We can have pi. I'm not going to do the integrals. I'll just leave this for you. This is a trivial integral. And you just get an answer, please. Just do it home. But anyway, if you get this, well, this is just like 95% of the work.
So
the rest
x
is
squared is the bottom function.
Sorry?
X squared.
Yeah, it's a bottom function because this x squared goes like that. Yes, the square root of x goes like this.
I mean the R2 in the bottom when you see.
This is R2 here. This is
Okay.
R1. So R1 is this function, yes?
Yes, I agree. I am with you. But in the bottom you chose x squared.
Which this one here?
Yeah.
Yeah, this is the bottom function, yes? This is your sample. This is the top function, correct?
Yeah, and the bottom we choose.
And this is the bottom function, which is this y equals x squared, correct?
Oh yes.
Yeah.
I guess no.
Okay, fine, fantastic. Okay, so let's just see that on animated. Okay, let's see. So again, so this is the top function, the blue one, which is the square root of x, And the bottom one here, yellow, is what? Is the x squared, and this is my sample. See, please note that you can move this sample. The minute that you are able to calculate the volume of one of these, then you are done. You've killed the problem. That's it. All what you need to do is just see where the samples will go. The samples will go vertically from 0 until they reach what here? 1, because we are calculating the sample position in the x direction, correct? All right. And then if you do the rotation, and this is what you get actually, right? Okay, and look at the sample. That's what the sample looks like. So it's actually the outer volume minus this inner volume, which is hollow. There's nothing there in the inside of that. Does that make sense to you, Asham? Is that fine?
Yes.
Yes.
Fine. Okay, so all right, let's just do some more interesting problems. So again, the whole thing here is nothing but if you put a, that's why when I said when we calculated the area, I insisted on putting the samples. You see, like very, very important. Now your sample here is just a strip, and you rotate that strip. So this is very important. The technique is extremely essential to do rigorously. Okay, here is another one. Let me just get the same problem here, the same problem, but I want to rotate it. Okay, let's just get another problem. That's not interesting. Okay, let's just see. I have x squared, x cubed about the y-axis. Okay, and I want to find the volume. Right. So what are you going to do about this problem? Okay, let's sketch x squared. So this is x squared. Okay. And x cubed goes like what? Which one is faster, Asham?
X cubed.
Okay, let me just delete that. Okay, now if so at 1 and 1 they agree, correct? Let's say that this is 1 and 1. This is, oh, sorry. Say that this is 1 and 1. This is 1 and this is 1. Okay, now which one is a bottom function? Which one is a top function here? So I have x cubed and I have x squared. So if x is 1/2, what is x cubed? If x is equal to 1 over 8, and this is what? This is 1 over 4, correct? So the x squared is higher, yes?
Yes.
Okay, so this is like x squared. Okay, and this is like x cubed. Of course, x cubed goes as such, yes, but we're not interested, yes. But after that, of course, the y squared is going to be less, and the x cubed is going to be more, yes. But again, that is not of our interest. So we will just stop this here. Okay, and let me just take this little bit. Okay, so this again, this is y equals x cubed, and the white one is the y equals x squared. Okay, and I want to rotate this about what axis, Shaban?
About y-axis.
About the y-axis. Okay, so let's see. Now, if this point rotates, this point here, yes, it should come here. Yes, you agree with me, Shaban? You agree?
Yeah, yes.
Okay, and now if you want to continue this, and this comes as such, and this comes, oh, that's not a good one. I changed the color. I am not a Picasso, but anyway, I'll try. Okay, so this should do it, right? And you can see that this is the object that you're going to get. Please note that this is filled, okay, and the rest is empty, hollow. Okay, so what are we going to do? We're going to take a sample perpendicular to what? To the axis of rotation, yes? And we will rotate that. Is that okay, Shalom?
Yes.
So if you rotate that, so what happens? You get this. Get this. So that's a sample. So let's isolate that. This is what you get. Now for that volume is pi, yes? This is R2, isn't it? And this is what? This is R1, you agree? It's R2 squared multiplied by the thickness minus pi R1 squared times the thickness. And the thickness here is what, Ashwa?
dy.
dy, very good. So this is my small volume. So if I want to get the total volume, so what do? Now I have to integrate, okay? I have pi, and now let's look at the thickness is a dy, and then I have R2 squared minus R1 squared. Okay, let's see this R. Let's look here. So this is your R2, isn't it? Yes, what Elijah?
Yes.
Yes, Doctor.
Okay, so let me just say that this is R2, and let me just remove that. So it is actually x of right function square. So this is horizontal, isn't it? This is horizontal. Is this horizontal or vertical?
Horizontal.
Right. So when you measure distances, you actually measure them in x or y?
Y.
Horizontal.
No, I mean the dy. Okay, next.
dy, but you measure distances. If you have a rod and you want to measure the length of that, how do you measure the length of that? You measure this x, correct? Minus this x, correct? And you get this
Yes.
x. For example, this is 7 and this is 3. So what's the length? It's 7 minus 3 in the x direction, isn't it?
Yes, of course.
Okay, so now the right function, the radius is just what? Is x of this blue function. Is this x? Now let's look at R2. So what is R2? Look here. This is R2. This is R1, sorry. What is R1? What is
X
R1?
of the left function.
Exactly, x of the left function. So this is x squared of the left function. And this left function happened to be what, Shabam? What is the left function? Y equals x squared. And this happened to be what? Y is equal to what? Is x cubed, isn't it?
Yes.
Okay, so this is what it is. Now look at these y's. Y is going, I'm going to take samples. So these samples will go from where to where? These are the samples, yes? Correct?
Yes.
And I will rotate them, yes? The red ones.
Yes.
They go from which y to which y?
From 0 to 1.
To 1, yes. This is 1 and this is 0. So you have to go from 0 to 1. Okay, this is enough, but anyway, let's just see how this happens. Okay, this pi goes out, so this is 0 to 1. Now I'm integrating with respect to x or y here, Yashon?
Y.
Y, so everything must change into y. So look at this x squared of this function. So what is this x here? What is this x? Is the cube root of y, isn't it?
Yes.
And then there's a square. We're taking x squared.
Yes, yes.
Minus, what is x here?
The square root.
The square root of y, and then we take in what also?
Squared.
Or take in squared. If you do this, then you get pi over 10. Home, please. Beautiful. Yes, very simple. So it all comes down from here. What's the volume of this fellow? It's pi r squared, the outer, times the thickness minus pi r inside square times the thickness. There is a common mistake. Common mistake is the following. You see now the formula in the book, I don't like formulas myself. So it goes from A to B, and then pi, and then y, let's say 2 squared minus y1 squared multiplied dx, etc. And I wouldn't really worry about this. And what I would do myself, I would just like look at this here. It's pi r squared times the thickness, basically, and identify that on the graph. Now, if you look here, there's some people do this. You see, like it's y2 minus y1 squared. This is not the same as y squared minus y1 squared. Do you understand this, Session?
Yes.
Yes.
Yeah, you must not at any given time just subtract the r's, which is r2 minus r1, and then square it times the thickness. This is incorrect because r2 minus r1 squared is r2 squared minus 2r1 r2 plus r1 squared. Yes. However, r2 squared minus r1 squared does not equal that. So you just be careful. I would suggest that you sketch your sample, put a sample. You don't have to have a decent sketch, a very decent sketch, but just a reasonable one is okay, and then you will just be fine. Here's another one. Okay, I have y squared x equal 2y about y equals 3. Okay, this is an interesting problem. Okay, so we have first of all, let's just on the side here, let's just sketch these graphs and know what we're talking about. What is this, Shabam? Sleeping
parabola around the x-axis.
Okay, it goes like that, exactly, yes. What is this? Is a straight line.
No.
Is it straight line passes through the origin?
Yes.
So what are we talking about? We're talking about this region, correct? You think so?
Yes. Yeah,
Okay,
find the intersection point. If you
exactly.
if
So
you need to make sure.
okay, let's find the intersection. Okay, so we're saying that x is equal to x is equal to that x. So what does that mean? That y squared is equal to 2y. So y minus 2 is equal to 0. So it means that y is 0 or 2. So this y is 2 and this y is 0. And corresponding to that, what is this value of x? 4, yes? Agree? Put y equal to, then you get the 4, yes?
Yes.
Okay, so we know everything about the graph. Okay, so let's just delete that and put it now decently. Okay, so we'll want to have a decent graph now. So we know that they intersect at 4 and 2, of course 0 and 0, 2, yes? Okay, so and let's just do that. Okay, so here. All right, so we have the straight line. We have that curve. Okay, and now they just intersect at 2, and this is 4. Okay, and I want to rotate this about what, Shabam? What is the axis of rotation? This is 1, 2, 3, 4, 5. Yes, this is my axis of rotation. Okay, let me just, for our mechanical engineer friends, we need to put a center line very well, yes? Otherwise they will be mad at me, yes? I was once an engineer a long time ago, but I didn't like it, so I changed my field. Okay. All right, so let's just rotate this about this axis. You understand this? This is y equals 3. تمام يا شباب?
Yes.
Okay, so let's just look at these points. If this rotates, this point rotates, where does it become, يا شباب?
At 4.
It will be here, correct?
Yes.
And if this point rotates, where does it become?
At 6.
So at 6, so this becomes here. Okay, let's just go to the and hopefully okay, so this is the object you're going to get. Something like this. تمام يا شباب. I don't understand why I have double lines here. Okay, let's just a small eraser. Okay, so we have that, and I think this line is needs to be larger. Okay, that's it. Okay, so this is the rotation. Do you understand what the object is now? So
Yes.
this is full of meat, yes? Full of meat here, and everything else is hollow. Yeah? Okay. Let's take a sample. We take a sample perpendicular to the axis of rotation or not?
Yes.
So this is my sample. Okay, let's rotate that sample. How does it look like?
Like ring.
Exactly. By the way, we have a name for that. This is called a washer. Ah, okay. I think this is reasonable from your instructor, a Picasso, right?
Of course.
All right. So let's just make this larger. So this is our what do we call this? This is a washer. This alone is called a disc. If you have a hole in it, yeah, sorry, there's no hole. Yes. If you have a hole in it here, then this is the name for it. It's a washer. Okay. So let's just delete the English language. So that's it. And so we have a washer. Okay. Okay. So let's just isolate this washer, and then try to find its volume. Okay. So let's just find the volume of this washer. So I will just get this washer here. This is my washer. Okay. So now, if I just want to okay, let's just do that. So from here to here is what? This is R2, yes? And from here to here is what?
R1.
Is R1. So what is the volume that we know? Everybody knows the volume of this, which is what? Pi R2 squared minus R1 squared multiplied by what?
T.
The thickness, yes? Which is that. Do you agree that the thickness is what here in this case, Ashon?
DX.
Yes, very good. So look at this red strip, it's a dx. So all I need to do is just find this nasty thing called R2 and R1. Okay, on the graph, do you agree with me that this is my R2?
Yes.
Yes, the smaller one.
No, it is not R2, is it?
Oh,
It is not this.
R1. R1.
It's not even R1. So where is that? Do you think
You
that
need to go. You need to go to the line of revolution.
this is
Yeah,
R2? Exactly. So this is R2, isn't it?
Yes,
Yes.
yes.
Okay, very good. So now, what about this from here to here now? Is R1?
R1, yes.
Okay, fine. So all I need to do is just find my measurements. That's all. That's all. So what is R2? First, it's equal to 3. It's equal to all of this, correct? Minus this, isn't it?
Yes.
Okay, so what is this?
The bottom function.
Okay. All right.
So 3 minus the bottom function.
Exactly. 3 minus y bottom. Okay. Which is equal to what now? What is the bottom function? Okay, let's just leave it. It's okay. So what about R1? R1 is equal to what? Is also equal to 3.
Minus
Minus what?
upper y.
Minus this here. You
Yes.
see that we're starting from here?
Yes.
And so this is from here to here. And this is your R1. And this whole thing from here to here is what? Is 3, yes?
Yes.
Okay, so what is R1? 3
3
minus
the upper function.
the top function.
The top, yes.
Okay. Do you understand this? Okay, let me just get another color.
Can you repeat it?
Yeah, okay, so let's just look at this. Let me just, maybe I should delete that. Do you agree with me that from here to here is your R1? Is that agreeable?
Yes, that's
Okay.
agreeable.
Yes.
And do you agree with me that from here to here is y of the top function? Because we are here, yes? Isn't it?
But I want to check, is the horizontal line the x-axis or y-axis?
Which horizontal line?
I mean the white horizontal line.
Oh, this one here?
Yes,
This is
x-axis.
this is the x-axis, obviously. Yes, this is
Yeah.
x-axis. Right. Okay, but now you see that I'm trying to measure this from this point. You see, this is my point of interest. Yes, remember?
Yes, yes.
Okay, so from here to here, okay, let me just from here to here is what? Is R1.
Yes.
R1, yes.
Okay, R1. And from here to here is what?
The top function.
Is the y of the function, the blue function, isn't it?
Yes.
So what is R1? R1 is 3 minus the top function, the blue function.
Yes, clear.
Okay, fine. So remember that now we are going to integrate now. So this is the volume. So you integrate and you have pi, and then this is a dx, isn't it? So this is going to be what? R2, which is 3 minus what is the bottom function now? In terms of x, yes, remember? What
2y.
what is exactly 2y? So this is going to be like 2y, but again, we in terms of x, yes? Because x is equal to 2y. This is the bottom function, correct? Yeah. So therefore, the y of this bottom function is going to be what?
X over 2.
X over 2, yes? Because we are integrating with respect to what here?
To dx.
Is a square. Minus 3 minus y of the top function. So what is y of the top function here? Okay. What is y of the top function? In terms of x?
Root of x.
The square root of x, that's it. So this is the square root of x. And we have a square. And we're going to integrate this from where to where? The samples are going to go from where to where? The samples are taken along what?
0 to 4.
0 to 4. And we're done.
0 to 4.
Yes, exactly. We're done with that. We got it. That's it. It's very simple. Okay. Let me just rotate this also problem. Do we have time? Yes, we have time. I will rotate this about the same problem. I will rotate this about the about x equal, let's say, x equal 4. Okay, I'll do the same problem about x equal 4. Okay, let me just get the 100% view again. Okay, so now I will take this problem again and do a rotation about x equal 4. Yes. Okay, let me see if I can. Oh, sorry. I don't know if I can take all that and clean it up. If I cannot, I'll just do another one. So let's see that. Okay, so let's just do some cleaning. I've lost everything. I have to come back again. Memory, sorry. Okay, so let's see if I can. I don't want to do this along this. Don't want to do that. Don't want to do any of that. Yes, not that. Okay, so this is gone. What I'm going to do, and I'm going to rotate this about. You gentlemen are following? Well, I've lost you.
Yes, we are with you.
Okay, so this is 2. I'm going to rotate. This is another example about x equal 4. Let's make it more interesting. So this x equal 4 is here. Okay, and for our, again, mechanical engineering friends, should be fine with them. Not very fine, but okay. All right, so how are we going to do this? Again, we will rotate, yes? So if you rotate that, okay, rotate this. So this is 4, and this is supposed to be another 4. And if you rotate that, then this comes as such, yes, yeah. And this comes as such. Let's just remove this damage. Okay, so this is what we're going to do. So if this rotates, then this becomes at 8, correct, Shama? So what are we going to do? We'll take a sample here. Okay, and we'll rotate. And if this rotates, okay. So this is your washer. You see that, Asham? That's here. Okay, fantastic. Okay, so let's just calculate the volume of this washer. So we know that the volume of this washer is pi. Okay, let's just look at R2 and R1. So from here to here, this is R2, isn't it?
Yes.
And here, at this point exactly, is R1. I hope you agree, Ashon.
Yes, we agree.
Okay. Now, but this from here to here, is exactly the x value of this blue function, isn't it?
Yes.
And now from here to here is what? Is this exactly correct? Which is what? Which is the x value of the white function, isn't it?
Yes.
Okay, so now if I want to do r2 squared minus r1 squared multiplied by the thickness, correct? Okay, so let's just do that. So this becomes what? Okay, let's just do that. So it becomes pi r2 is actually from here to here is what?
4 minus
4.
4 minus
the blue one.
x of left function, correct?
Yes.
Squared, yes?
Yes.
Minus 4 minus x
Of right function.
Squared multiplied with the thickness, which is in this case
dy.
And you want to integrate that from 0 to 2, correct? Because you have to go the samples here. Okay, so what is the x of the left function, Asham? The blue function. The blue function was what? Okay, let's just put that. Y squared is equal to x, and x is equal to 2y. This is the straight line. Okay, so this is going. So the volume now is going to be from 0 to 2. Okay, so this is pi 4 minus the left function, and the left function actually is the blue one, which is this, correct? And you have to change that. X is equal to y squared, isn't it? Right? Minus 4 minus x of the right function, which is 2y. And there is no need to change anything because we are integrating with respect to what, Ashram?
dy.
dy. And then that's it. You have it. So if you do that home, Allahu A'lam, you get this number. Please check home. Okay, so I hope you have a little understanding of this. Until next time, I'll do more problems for you, inshallah. We will see what happens. Okay.
دكتور.
Yes, with respect to yes. نعم تفضل.
زاد فضلك. أنا ترى دكتور كلمتك قبل أمس أو قبل أمس تقريبا عن الكويز.
Yeah, can you talk to me at 11:15, please, when I finish my other class? From 11:15 until 12:30.
Is there any time because I have a lab in this time?
طيب.
Sorry.
I will just log out of this session وكلمني على طول الحين. طيب.
طيب.
Okay. طيب. Any other question يا شباب? Don't forget your checkout quiz يا شباب. يلا السلام عليكم.